With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, so we are given with the question which says a square frame wire ABCD of side 1 meter has total resistance of 4 ohm. It is pulled out of the magnetic field having value as 1 Tesla by applying a force of 1 Newton, as we can see in the figure. It is found that the frame moves with constant speed. First we need to find this constant speed. Second, the EMF induced in the loop. Third, we have to find potential difference between A and B, and finally we have to find potential difference between C and D. Alright, so let's begin. As we can see, the loop has been moving or pulled from the magnetic field. So this is the case of motional EMF, and for motional EMF we can say induced EMF E will be given by the formula BVL. Alright, where L is the length. So we can say let's say this is our equation number 1. Also, since the EMF is induced in the loop, so we can say current will be flowing in the loop, and we can say we know this current, that is I, is given by the formula E by R. Alright, by Ohm's law we are writing this, so we can write this as BV L by R. Also we can replace this CD section, as we can see, by a battery source. Alright, so if we try to draw it over here, so this section behave as if it is a battery source, and the cause of this battery is the motion. Alright, or we can say this is a battery source having a potential of BVL. Alright, and here it is the positive terminal and negative terminal. This we can decide with the help of right hand palm rule. So force is in this direction, that is velocity is in this direction, and magnetic field is inward, so upward, that is C will be a positive potential and D will achieve a negative potential. So this will be the battery as we have shown over here. Alright, also we have been given with the value of B, we have been given with the value of force, and we have with us the resistance value also and length value also. Just we have to calculate the value of I. So for I we will we know when a conductor is placed in a magnetic field carrying current, so it experiences a force which is given by F equals to ILB. Alright, and here we can see the length, the angle between length, that is this length and magnetic field is having an angle of 90 degrees, so we can write this as ILB, and from here we can say I will be nothing but F by LB. Alright, so this is what the, since force has been given, so current will be this, current will be F by LB. Therefore from equation, if we substitute this value in the above equation, we can say therefore instead of I we can write F by LB, and that is equals to BVL by R. Alright, so what we can do over here is we can take a single notation for everything, so we can keep it as L only. Alright, so from here we can say the value of V, that is constant speed, we can calculate it as V will be nothing but FR divided by B square L square. And if you substitute the value, F is given as 1, resistance is been given as 4 ohms, dividing it by B square is 1 into L has been given as 1 meter, so this value comes out to be 4 meter per second. So this is what the velocity or the constant speed we are getting. Now in the second part of the question, we have been asked to calculate the EMF induced, so we can use equation 1 for it. From 1 we can say E is nothing but it is BVL, and we have just calculated the value of V, that is B is given as 1, V we have calculated as 4, L is given as 1, so this comes out to be 4 volt. So this is the value of EMF induced we are getting, and finally we have to calculate the potential difference between AB and CD. So for this we will try to understand it over here. This is the B part of the question. For C part, as we can see, if we redraw the circuit over here, so or the loop over here, so this can be this is the loop, and here it is the battery source, that is we have proved over in the above section. This point is our C, D, this is A and B. Alright, so first let's talk about CD. So here we can see the current will flow in this direction. As we have seen, C is at positive potential, D is at negative potential. So a potential difference across CD can be written as, directly we can write potential difference across CD can be given by the value I into RCD, and we know RCD is nothing but resistance of the loop CD, so it has been given as 1. Since total resistance of the loop is given as 4 ohms, so for CD it will be 1. And I we have calculated, I we can calculate by using F by LB. So F by LB, that is 1 by L into B, that is 1 into 1. So this value comes out to 1 volt. Alright, so we can give the reason over here, since I is nothing but it is F by LB, or we could have used directly E by R. So from there also we would have got the same result. So this is about the CD. Now we have to calculate the potential difference across A and B. So for this we have to take the terminal potential difference, that is terminal potential difference, that means these 2 points we have to consider. So we can write, this can be written as VBA, as we can write it as E minus of IRAB. Alright, so from here if we substitute the values over here, E over here is small e we can take, that is the EMF of the battery. So this is 4 minus of I, we have calculated 1, and the resistance is 1, so this comes out to be 3 volt. Alright, so this is the potential difference across AB we are getting, and this is our C part, and this was our D part. Alright, so we have calculated all the 4 required values, and I hope you have understood the concept, and thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.